Good morning and welcome to Surviving the Kubernetes Jungle, which is going to be a crash course into Kubernetes in 30 minutes. This is going to be interesting. For everyone who doesn't know me, probably everyone knows me. If you've ever asked a question about metrics monitoring, logging, continuous integration, continuous deployment, or R2D2, you've probably got an answer from me or one of my colleagues. I've been in all of these teams. We're really short on time, so let's get started. Oh, wow. All right, before we get started, I'm going to teach you a bit about preparing a presentation. Lesson 1, if you pick a title, choose it wisely, because Kubernetes and jungles, that didn't work out that well. Turns out that if you're doing containers, it's a lot easier to find images that are shipping related rather than jungle related. This is one of the first images that came up, which is a container that got stuck in the jungle, and that's not what we want. Okay. Lesson 2 in prepping a talk for the Spaces Summit. 30 minutes is not a lot of time, especially if you want to cover a lot of ground, like a Kubernetes cluster. So it will be completely impossible to teach you everything about Kubernetes in 30 minutes. So I'm going to stick to the basics. And sticking to the basics means a couple of things. And we're not going to do much of the bol.com specific stuff. We're just going to focus on Kubernetes as a platform. There won't be any R2D2. It's just plain Kubernetes. And advanced concepts like Istio will be ignored altogether. The good news is that basically everything we're gonna show you today in practice, you can do yourself on your laptop, like no external dependencies. Use any of the software on the screen to get that working. Okay, Kubernetes is all about orchestration, because Kubernetes is a container orchestrator. Where Docker was built to manage containers on a single computer, Kubernetes is the thing that scales containers to a much larger fleet of servers, which are called nodes. There's a little drawing in the bottom. We'll get back to this later to get into more detail on how Kubernetes actually manages a multitude of nodes. But to get working with Kubernetes, we need to dive in and start interacting with it. And to actually do that, there's a tool called kubectl. Yes, it's pronounced kubectl. I was at KubeCon a few weeks ago. Some people from the actual kubectl team were there, and they settled the score in their talk. They actually said it was kubectl, and then went on to call it kubectl for the rest of the talk. I will do the same. I will probably call it kubectl, because that's what we call it usually. And it's the command line tool for Kubernetes. And it's a great tool as well. It has a lot of functionality, but in the basis, all it does is transform everything you give it into HTTP API calls and feed it to the Kubernetes master, which has an API server. It uses the same calls that Kubernetes will do itself when it's communicating with the system. I'm going to show you that in a bit. And I think one of the most important things to note is that kubectl is not limited to one cluster. You can interact with multiple clusters using the same tool. And I think in the end there will be a bit more about that as well. Okay. As I said, Kubernetes is for larger clusters. There are multiple servers involved. And to make that economically viable, you need to host multiple applications onto a single cluster. To do that safely, do that in a controlled way, you need something called compartmentalization. And I said it right the first time. Eat that, Maarten Derksen. That was a fun interaction at the Spinnaker Summit. So what we're going to do, before we're going to deploy any containers onto Kubernetes, is divide the cluster into namespaces. And a namespace is basically Kubernetes' way to do multi-tenancy inside a single cluster. You get a small bit of space in the cluster, or the size of your space is actually defined by the quota. And it provides security through isolation. Your resources run in the confinement of a namespace, and someone else's resources run in the confinement of their namespace. You can interact between namespaces, but it's all based on rules. To get the demo started, let's create an actual namespace within the cluster. For this demonstration, I'm going to be using Kubernetes on my laptop. It's going to be powered by Docker for Mac. You can also use Minikube or Kind or any of the other software. This was the one that was easiest to use for me. And to get a namespace started, we can do that actually in multiple ways. First, we can get a list of all the namespaces in the cluster, which are not very much namespaces, because this is an empty cluster. This is basically what you get when you install Kubernetes somewhere. To get a namespace for our resources, we can apply a YAML document which has the basic definition for a namespace. And it doesn't get much simpler than this, right? It's kind namespace, and it has a name of jungle. To apply this to the cluster, we can apply a file, -f, source is a file. And Kubernetes will tell us that a namespace has been created. So if we do the same command we did before, we actually have a namespace called jungle. We can also ask Kubernetes about the details of this cluster, of this namespace. And there won't be a lot of details anyway, because we didn't give it much details to begin with. All right. Next step. If you notice my command prompt, there's a bit of Kubernetes information in there. First of all is the cluster name. I'm currently talking to my Docker for desktop cluster. And I'm currently in the default namespace. This is very useful to know what you're actually dealing with. If you have multiple clusters and multiple applications, it's really easy to get to lose track of all the resources. So keeping this close is a really useful way to avoid mistakes. I can switch a namespace to the jungle namespace, and you will see that my command prompt will update to actually be talking to this new namespace. All right, that's enough about namespaces for now, I guess. So let's get to deploying a container, because that's what it's all about, right? This is a container hosting platform. What we're going to try to do is put a container on one of the nodes in our Kubernetes cluster. Well, not exactly. And this is where things get a bit funny, because a container is not the smallest manageable unit inside of Kubernetes. They have a wrapper around a container, and it's called a pod. But one does not simply deploy a container in Kubernetes. So every beginner is probably faced with this issue, like, okay, so what do I do to my container to make this work? And the answer is pods. They are the most basic building block inside of Kubernetes, and everything you'll see as a resource in Kubernetes is probably wrapped in a container. Like every container is wrapped in a pod. A pod is not necessarily containing one container. You can put multiple containers inside a pod. And those containers will share the same network, so they're like on a local LAN. And they will always be hosted on the same node, so they stick together as a unit. As such, it is a symbiotic link between containers. Okay, now that we got that out of the way, let's try to actually deploy a pod on the cluster rather than a container. Again, same with the namespace. This is going to be pretty straightforward. We have a YAML spec resembling a pod. We'll put some metadata in there. The most important values are its name and the namespace the resource lives in. And then the usual Docker stuff, like inside the actual pod is a container, and the container has a Docker image. Okay. So let's try to launch this stuff. If you notice my command prompt, you'll notice that we're still inside our Jungle namespace. There are currently no pods running on the cluster. But we can watch for pods as they may or may not enter the namespace. Okay. So let's try applying this resource. And it's actually working. So you'll notice that while we watch the state of the containers, of the pods actually, you'll see it go from state pending into container creating into state running, which basically means the Kubernetes has launched a container for us. So I'm going to use some abbreviations of my commands to speed this presentation up a bit. So KGP is Kubernetes, kubectl get pods. This saves you a lot of typing. And we currently have one pod running on the namespace. Right. Well, that was very cool. But what did we just do? What actually happened on Kubernetes while we performed this action? Because this is all a bit magic still. To actually find out what happened, we can do a couple of things. So the pod we just, of course, I have to define. The resource. And the description of the pod will give you a list of events that actually happened while launching the container. And this is a very short list of events because obviously this launch went very well. But this is really useful when things go awry, when something is happening what's not supposed to happen or you didn't expect it to happen. You can look at the events to find out what happened. To see all the events that have been happening in the namespace, you can do a kubectl get events. So these are not limited to just the pod we just launched, but everything that's going on inside of your namespace. It's basically the same list because, well, we only launched the one container, right? All right. Now that we have a pod, we can start doing stuff with it. First of all, viewing the logs. Viewing logs of your container is obviously important because you want to know what's going on inside your container. This is basically the same as you do in Docker, just the command is a bit different. I'm going to give you one great tip to actually view the logging, and that's to use stern rather than the kubectl commands for logging, because stern is much more intuitive. We'll get to that in a second. And if you want to view historic logs for your containers, like the live logs only have the past couple of minutes. But if you need to see last week's logs, we actually store those for you, and you can use Kibana like you would do for any other logs to view your container logs. We can also launch a shell into a container. Basically, again, just like Docker. This doesn't work where containers don't contain an actual shell, like really, really small containers. They don't have a shell, so you can launch it. And most containers are not running as root, so you might not be able to do everything you want to inside of a container. I'm going to show you this in a second. Let's show it right now. So first, let's set up some logging. So we can till the logs. The -f command means follow, so we're still following the logs of the container, but there are no logs yet. This is a very simple container. It didn't have any output when it started, and we haven't done anything with it. So in order to enter it, we'll do an exec, and we'll launch a shell into the container. So we're actually talking to this container right now. And we can see what's running inside of the container. So this is a Node.js container, and it's running a file called server.js, which is a really, really elaborate script that just returns hello world with HTTP 200. But the interesting thing here is that it listens on port 8080. So that means that if we can curl localhost on port 8080, we should get a response. And we did. And we also got a log event, because log events are emitted to the log. Okay, well, that's cool. That's working. I'm going to show you Stern as well. And Stern is an abstraction over logging, and it makes it really easy to select the logs you want to view. So if we have a list of pods here, we only have the one, which is called demo pod. But I can use Stern demo, and it will show you all the logs for all the containers that contain the word demo. And that's pretty great, because if we have multiple containers or a high available service, there would be multiple pods running. And you probably want to tell all of them so you can get a complete overview of what's happening to your application. Well, that's basically it. You can do a lot more cool stuff, but read the manual if you want to. Okay, this slide is called the porta potty, because we're going to connect to a port on a potty. And connecting to a port, yeah, I know. Connecting to a port is really useful to see if a container is actually working, if it does what you expect it to do. Sometimes you don't want to expose a container to the outside world, but you want to see what's happening inside. And for that purpose, we can use port forwarding. All right. So I have a browser on my local computer. All right. Shell is misbehaving. Right, there's a glitch in the matrix. Obviously, doing live stuff always fails. Oh, wow. Right, that doesn't really help with the demo, does it? Well, okay, I guess we're going to skip this. Trust me, this command works. It's not rocket science, really. You just connect the port on your laptop to a port on the pod in the cluster, and you can use a local host connection on your workstation to connect to that port. Still not working? Nope. All right, let's talk a bit about metadata, because we've been talking about pods and containers, but it's really important to classify stuff inside of a cluster. And there's two ways you can do that. One of them is labels, and labels are basically what they say they are. They're key value combinations, and they are used to identify a pod, not by a means of a name, but you can group them together, and you can efficiently query a set of pods that have the same label. A bit more on that later. Annotations contain non-identifiable metadata, which is often used by plugins and other stuff to retrieve a value about your containers and do something with it. Like you can assign your resources a DNS record based on an annotation. There's a lot of stuff on metadata. Please read up on it, but at least we covered the basics. Well, with the shell not working, we're not going to do editing a running resource, but you can basically do kubectl edit on a running resource. You get a Vim editor, and you can basically change around values and store them. You can copy files to and from containers, which is really useful if you want to retrieve like a configuration file or a log file from a container, or you need a resource to be present on the container to debug it. Please remember that once you restart a pod, the container is gone, and as will your copied files you stored into the container, because this is immutable infrastructure. Last but not least, most of the resources you put on a cluster you can actually delete. And this would have been great to actually demo, because as we were deleting a pod, you can actually see that a pod would be deletable. And we're getting to resources where it gets a bit funky in a second. Okay, so that's the basics. If we're stepping up our game, let's talk about a bit about selectors. A selector acts on the labels, like I previously mentioned. I have a selector in the bottom, and it selects all the pods that have a component label of Redis. So, given 4 pods, 2 of them have the component is Redis label, 1 of them is a different component, and 1 of them doesn't have a component label at all. If we're going to select on this selector, the 2 pods that don't have the component is Redis label are not selected, which is really easy, right? Okay. Next, let's talk about replica sets, because managing pods is nice, but it's basically doing Docker on multiple servers. To do anything useful with it, like high availability, you need to ensure that the containers are always running, and this is where the replica set comes in. So a replica set is a wrapper around some pods. You can define the number of pods a replica set is supposed to be running based on a template. Oh, wow. This is going great. Fantastic stuff. So I can't even show you the file that contains the replica set because it was in my other demonstration slides. Okay, let's move right on, and this is going to be a theory talk rather than a demo. Okay. A little bit about what happens when you launch a replica set into a cluster or any resource, really. kubectl will talk to the API server, and it will give it its request, and that will interact with the components on a Kubernetes master, which has a controller manager, a scheduler, and a storage backend that actually stores your YAML files. If we feed it a new replica set, the controller manager will notice that there is a new replica set, and it has to act. The replica set will be stored in the storage backend, and the controller manager will say, okay, so we need a couple of replicas for pods, and it creates those pod resources for you. Next up, the scheduler notices that there are pods that are not on the cluster yet, and it will actually choose a node that has capacity available, and it will talk to a component running on that node, which is the kubelet, which is the only thing Kubernetes runs on a generic node. There's a couple other components as well, but this is the most important one. And the kubelet is actually responsible for scheduling Docker resources on the node. And the kubelet will take care of launching the containers for you. It's obviously more complicated than this, but this is the most basic overview I can give you. Now that we know what a replica set is, let's talk about deployments. Because replica sets are hard to manage. Deployments are actually a wrapper around replica sets that make it more easy to manage. And it comes with some added features as well. There is use for replica sets, however. If you do not want to manage, automatically manage deployments on Kubernetes, but want to really interact with how a replica set scales up or down, you can use a replica itself. And Spinnaker, for instance, uses replica sets to control the way it deploys resources. But that means you have to do the legwork, and Kubernetes can do the legwork for you if you use a deployment. So for the bigger picture, we have a namespace running in our cluster. We're going to launch a deployment into that namespace. The deployment will create the replica set for us, and the replica set contains a set of pods. Now, if we update the deployment, something funny will happen. So we're going to apply an update to the deployment. Like, say, we're going to update the version of a Docker container. The deployment will do an automatic rollover by creating a secondary replica set, which contains your new version. It will launch a container in the new replica set. Then it will remove a container in the previous replica set, launch a second container in the new set, remove the second container from the old set, and remove the old replica set altogether. So this is called a rollover. I was obviously going to demo this to you, but whatever. If you want to know more about deployments, I highly recommend you join Timo's talk this afternoon, From Simple to Advanced Deployments in Kubernetes. He's going to talk about some really cool stuff that's upcoming to our landscape. He's going to do sneak previews. There's other type of workloads as well. You can see them over here. This is obviously a basic intro, so we can't talk too much about them. The most important one to notice is, I guess, CronJob, which allows you to use Kubernetes as a cron scheduler. Storing data usually happens in config maps and secrets. Those are basic resources that can be mounted into a container and store data. And this is how you keep your containers generic and have the configuration able to move with clusters. If you want to do more data, we have a concept called persistent volumes. If you mount a persistent volume into a container, it becomes stateful, and stateful applications are harder to manage. Keep this in mind. Okay. We're running out of time. We have 1 minute left. So I'm going to skip the communication bit, which is really interesting, but takes too much time. All right, I have some productivity tips for you. You saw me use a lot of shortcuts. This is the slide you want to take pictures of, because this is going to improve your workday. I'll share more slides later, maybe do another session to actually present the rest. If you want to know more, these are the resources I use for this presentation. These are some great reading tips if you want to know more about details. This was obviously very shallow. If you want to train yourself and you don't want to do it on your laptop, please use our quick labs because they're free and they have really great trainings into all kinds of subjects, also the advanced subjects. We didn't get to a lot of things. We didn't get to half the presentation. And that obviously means we don't have time for questions as well, but that doesn't matter because me and my colleagues will be at the Google Cloud booth downstairs all day answering questions about GCP, Kubernetes, everything you want. So if you have any questions, please find us there and ask us the questions. Thank you very much.